Hi everyone, Dr. Vaughn. In this video, we're going to look at question 16.9, which is a simple one-factor ANOVA. We have a very small data set, and we're going to compute the ANOVA table using the computation formulas. So I've actually typeset these computation formulas from your text right into this Word document over here for easy reference. The one thing that's going to be important to recognize is that T and G are actually the totals and not the means. And yet in the problem statement, they're giving us the group means and not the totals. All right, so we'll go forward with computing first this SS between, which is where I want to total sum take each of the group totals, square them, and then divide by the number of items that are in each group. So, and then we'll subtract off the grand total squared divided by the total n over there. So I'm going to do the work on a calculator as we go through. So for the first one, I'm going to total 3, 5, and 7, which should be 5 times 3 because there's 3 items. So this will add up to be 15, and if you divide by 3, you get the group mean. So I can get the total either by adding these numbers or by taking the group mean times 3. So for the first term, I'm going to take 15 is the total. I'm going to square that, and then I'm going to divide by 3 items in the group. For the second column, I'm going to take 6 times 3 is the sum is 18, so I'll take 18 squared divided by 3. And for the third column, I'm going to take 4 times 3 is 12. So there's the total for column 3 is 12, so I'll take 12 squared divided by 3. So that's my t squared divided by n, sum them all up, and I'm at 231. So now I need to take the grand total, square it, and then divide by the big N, which is the total number of data items in my set. So the grand mean is 5. There were 9 data items in here. 5 times 9 means that if I added up all 9 of these numbers, it would add up to be 45. So I'm going to take this 231 that I got and subtract 45 quantity squared and divide by the total number of data items, which is 9. And I get the sum of squares between of 6. Now for the sum of squares within, we're going to take this, the sum of all the scores themselves squared minus this sum of t squared over n. Now this sum of t squared over n is that 231 that we just computed right up over here. So this time I'm going to just remember the 231, and I'm going to go back to my data and take all 9 of these regular scores and just square them and add them all up. So 3 squared plus 5 squared plus 7 squared plus 4 squared plus 8 squared plus 6 squared plus 2 squared plus 4 squared plus 6 squared. That turns out to be 255. I need to divide, I'm not dividing this by anything, so that's 255 minus that first part of this sum, which that's that number I was remembering, so that's minus 231. 255 minus 231 gets me to 24. So the sum of squares here is a nice even 24. And then the sum of the squares total, I could actually use this formula, or I know that the sum of squares between and the sum of squares within adds. So I get a total of 30. Now for the degrees of freedom. For the between category, this is the number of groups minus 1. So 3 groups minus 1 gives me 2 degrees of freedom. The within category is the total number of data items minus the number of groups. So you got 9 data items minus 3 groups gives me 6. And the within, the total is the total number of data items minus 1, which is 9 minus 1 is 8. And it's also the sum of 2 plus 6. So for the mean squares, we're just going to divide. Sum of squares minus degrees of freedom. 6 divided by 2 is 3. I don't even need a calculator for that one. And 24 divided by 6 is 4. Don't need a calculator for that one either. And then finally, for the F statistic, I'm going to take the mean squares between, which is 3, and the mean squares within, which is 4. 3 divided by 4. And I don't need a calculator for that one either. It's 3/4 or 0.75. That's our F statistic, and that concludes question 16.9. Have a great day.